Shock Mechanics 1A. Choose from pivot, load, and effort to identify x, y, and z. X equals effort, y equals pivot, z equals load. 1B. Is the lever acting as a force multiplier or distance multiplier? The lever is a force multiplier. 1C. Should y move closer to x or closer to z to reduce the force needed? Y should move closer to z because this increases the effort arm. 2. Describe the type of equilibrium shown in each diagram. A. Neutral equilibrium. B. Unstable equilibrium. C. Stable equilibrium. 3. State whether each object is a first-order, second-order, or third-order lever. A. Stapler, third-order lever. B. Pliers, first-order lever. C. Nutcracker, second-order lever. 4A. Convert the speed limit of 60 km per hour into m per seconds. 60 pro to frac 60.0 times 1,600 is 16.7. 4B. Find how far the car traveled between the first and second photographs. The car moved about 8 road spaces. Each space is 2.00 meters. D equals 8.0, 2 equals 16.0 text M. 4C. Calculate the speed of the car and decide if it exceeded the speed limit. S 16.0, 0.500 equals 32.0 sectos per stones. Since 32.0 ms per second, 16.7 ms per second, the car was exceeding the speed limit. 5A. From the velocity time graph, identify when the car is slowing down, speeding up, and traveling at constant velocity. I. Slowing down. C. Speeding up. A. Constant velocity. B. 5B. State the fastest velocity of the car in m-secs and km per hour. Fastest velocity equals 20.0 meters per sec. 20 point times 3.6 equals 72.0 text 0. Answer. 20 point meters sec equals 2.0.0 per hour. 5C. Calculate the acceleration in the first 50 seconds. A equals frac 10.0, 50.200 text to a 2 nax. 6A. Is the spanner acting as a force multiplier or distance multiplier? The spanner is a force multiplier because applying a force far from the nut produces a greater turning effect. 6B. Calculate the moment on the nut and state its direction. T equals 100 at time 0.15 do and T equals text moment equals 15.n meters clockwise. 6C. Explain why using the hollow pipe gives a greater moment. T equals FD. The pipe increases the distance d from the nut. Since T depends on d, the same force gives a larger moment. 7. Show which solid shape is least stable and which is most stable. Least stable, A, because it has a narrow base and higher center of gravity. Most stable, B, because it has a wider base and lower center of gravity. 1A. Complete the thermometer scale between 0 degrees Celsius and 100 degrees Celsius. The thermometer scale should be marked evenly from 0 degrees Celsius to 100 degrees Celsius. 1B. Mark cyclohexane's melting point and boiling point. Melting point, MP at 7.0 degrees Celsius. Boiling point, BP at 81.0 degrees Celsius, 1C. State the physical state of cyclohexane at room temperature. Cyclohexane is a liquid because room temperature is between 7.10 degrees and 81 degrees. 1D. Give 2 other properties of mercury that make it suitable for thermometers. Mercury expands uniformly and is easy to see. 2A. Explain why the thermometer may not show the average temperature of the water. The thermometer bulb is close to the heat source, so it may measure hotter water near the bottom instead of the average temperature. 2B. State how the student could obtain a more accurate temperature. The student should stir the water and place the thermometer bulb in the water without touching the beaker. 2CI. Read the start and end temperatures. Start temperature equals 8.0, end temperature equals 34.0 dur. 2C. Calculate the increase in temperature. Delta T equals TF minus TI. Delta T equals 34.0.826, 26.0 Chicago. 2DI. Predict what happens if more heat is given to the same volume of water. The temperature rise would be greater. 2D. Predict what happens if the same heat is given to a larger volume of water. The temperature rise would be smaller. 3AI. Suggest what material X, the panhandle, could be. X could be wood or plastic. 3AI. Explain why X is suitable. Wood or plastic is a poor conductor, so the handle does not become too hot. 3B. Suggest what material Y, the pan body, could be. Y could be metal, such as aluminum or steel. 3B. Explain why Y is suitable. Metal is a good conductor, so heat passes quickly to the food. 4A. State the change in the apparatus after the flask is held in the hands. The colored water rises up the capillary tube. 4B. Explain why this change happens. Heat from the hands warms the water, causing it to expand and rise in the tube. 5A. State which ice cube melts more quickly. The ice cube in test tube B melts more quickly. 5B. Explain why the ice cube in B melts more quickly. The lead wire keeps the ice cube near the heated end, so it receives heat more quickly. 6A. State 3 things kept the same for a fair comparison between the cans. Same volume of water, same type and size of can, and same distance from the heater. 6B. Name the main process by which heat is transferred from the heater to the cans. The main process is radiation. 6C. Plot temperature against time for cans A and B. Plot time, minutes on the x-axis, and temperature, the degrees C's on the y-axis. Plot both can A and can B on the same grid. 6D. Explain the difference between the graphs for the two cans. Can B's graph is steeper because the dull black surface absorbs radiation better than the shiny silver surface.